Yeah, that's better.
So, hello everyone, this is Recitation 3, which is about the debugging in the context of the deep learning. And since the content is relatively simple and the debugging is really a case-by-case problem, so this recitation will be very short. And anticipate that we will finish within 20 minutes. And for the rest of time, you can ask questions about the homework 1, part 1 and 2 for the projects. So, and you can also leave if you don't have any questions. And before we start, I want to notify you guys that we have released the cutoff of the homework 1 part 2 yesterday. So as far as I know, you need to reach at least 75% accuracy to reach an A level. And for this, I have a general ideas for you to refer. First, you can build some simple architecture if you haven't started your homework 1 part 2. And this will make sure you that the entire pipeline works. If you haven't begun the part 2, you can try the architecture we released yesterday. This will lead you to the B grade. After that, you can try to make the neural network deeper and wider. Then make sure you record all the architecture you used in an evaluation sheet. You may try different combinations of the architecture and the training strategies. I will talk about what you need to record in the evaluation sheet or the configures you should record later in this recitation. So let's begin. In this recitation, we will be covering some basic concepts of the training in the PyTorch. And you should have been familiar with those concepts, but we just want to make sure you don't encounter errors due to the misunderstanding of those concepts. After that, we will talk about what you should record when tuning the parameters. This is very important, especially for the following homeworks 2, 3, and 4, or even your project, which you need to spend more times on the parameter searching. And Sheila will talk something about the debugging tools and show you how to use them on a remote notebook. And we will also leave the notebook for you to reference, and you can use the start code if you haven't begun your homework part 2. So let's first talk about the data in the PyTorch. To train neural network, we need to convert the raw data to a PyTorch tensor. And for a tensor, it has several attributes. For example, shape, type, and the device. Data error caused by the mismatching of those 3 attributes are most commonly encountered. Here we show a 2-dimensional example of the PyTorch tensor. In practice, it may be more dimension due to the batch and time dimension. And make sure you have checked the data shape before you send them to the model. Moreover, for the data type of a tensor, most of the time, the input of a neural network should be a float tensor. And for the label provided to compute the loss, it should be a long tensor. And this is what happened in your homework 1 part 2. So make sure you check the data type and shape before you train a neural network. The PyTorch tensor also have a device attribute. And you need to send the data to a device before you begin training. If you choose CUDA device, data will be sent to GPU. And if you have multiple GPUs available on the server, you may need to assign GPU IDs. But for this course, 1 GPU is enough for all the homework. In case you want to use multiple GPU in your project, I recommend you to run your model using the distributed data parallel instead of data parallel for multiple GPU training. And because it is more efficient to run the distributed, to run the neural network in a distributed manner. Here we give some examples to check the data correctness. First, the easiest way is to use the print function in the Python. And you can easily get the data attributes by using the getter function of the class. And on the right side, we present the outputs. We will show a notebook to run this for you later. Another suggestion is using the assertions in your code. Assertions can provide you checkpoints in the code, and this way you can easily localize the errors if you encounter some unclear data or some problematic implementation in the data loader. Here we show some assertions which used for check the data shape and data type. And when you write your assertions, make sure you give some hints for yourself to reference if the assertion is triggered. And we'll talk about something about the model in the PyTorch. Similar to the tensor, your model needs to be sent to a specific device before training. It can be either GPU or CPU. And one of the most commonly encountered error is the model and data not on the same device. For example, the model is on the GPU, while the data is on the CPU. In this way, you will get a coda error. This error can be easily solved by putting data and the model back to the same device. But we will recommend you to check the device attributes before training. And you can manually add these two lines before your training loop and use the assertion to double check it. Another commonly encountered error is about the mode of model. The model have two different modes regarding to the training and evaluation phase. In the training phase, you should explicitly set the model.train so that you enable the batch norm to update the statistic values and enable the dropout if applicable. Don't worry if you don't know what is dropout. And you will know that in the next few lectures. And if you run on the evaluation mode, the batch norm will begin to use the learned statistic values, and the dropout will begin to average all neurons. Beyond that, another thing to observe to mention is about the gradient computation in PyTorch. You must put all evaluation code in the context of the torch.noGrade to truncate the backward propagation. That will make your evaluation code runs faster, and it can be more. It can also save your memory. If you encounter maybe out of memory error, you can try to verify that you add the torch.noGrade. There is an example to print the model architecture. And for the WandB share, I will talk about the debugging tools later. And I also recommend you to record each of your experiments. And there are two tools that can help you. First one is the arc parse, which can let you change the network parameters using the command line. And I also attach the links which you can check after the recitation. And another one is the YCS, which we will give you YAML each time you change the parameters, and it can in this way you can save your model architectures. This will help you revisit them if you want to maybe self-training or something, some tricky techniques used in the in your network training. And another thing I strongly recommend is the evaluation sheet. Here it shows an example of the evaluation sheets I created in the summer, and maybe I can show you Excel. So Sheila, could you see my screen? The Excel.
Yes, I can see it.
Oh, yeah, okay. For evaluation sheet, you should record the model you saved. It's the checkpoint you saved, and just read the saved directory, and some training parameters you choose, such as batch size, base learning rate, and you won't use the dataset column because all the data are used in the same dataset, and maybe some other model architecture. You can choose. This is convolutional layers, but for your homework part 2, it can be maybe the hidden layer numbers and the neural numbers in each network, and also record the maximum iterations or epochs you use in the training, or the initialization method of the neural network. For me, I also have some additional column to record the tricky I used in the training. And for this one, you can use more and more trickies until you get a good result. And the last few columns are used to record the performance. And for the homework one part 2, you should record the accuracies of the network. You can also use read some notes, and maybe some you may find some bug and fix some bug in some time. And you can use some different colors to represent different training strategies or data set that can be changed. If you have multiple implementation, you can just add one page. So I recommend that is because in the last semester, and I want to revisit some of my saved checkpoints. I just don't know what they are. So just make an evaluation sheet to ensure you can remember all the training details of each experiment. Well, Sheila will go through the debugging tools and show you the 2 examples using a notebook. Yeah, Sheila.
Okay, let me share my screen. Are you able to see my screen?
Yes.
Okay. So I'm going to cover WandB, but the Notebook also includes code that can help you understand how best you can debug using print statements as well as assertions, as Xiang mentioned. And I believe PDB was covered in the recitation 0 for debugging. It's a really useful tool, so you can consider it. And as of Python 3.7, they introduced a breakpoint method that you can consider. It has the same functionality with PDB debugger. So maybe you can just look at the documentation and learn how to use it. It's quite simple. So we use WandB mainly to track our model parameters, and you can also use the Google Sheets. I have linked a different sheet. It serves the same purpose as the one that Jiang just showed you. So you can just decide to use either of them. It's good practice to use them so that at least you can understand what helped your model to perform better and what wasn't very useful. So I saw someone in the chat asking if you need to have it or if you need to submit it. No, you don't, but it's just going to be helpful for you. Okay. So this is just the normal imports, but the interesting bit starts here. So the first thing you need to do is you need to create an account on WandB. There are pictures on the slides that can help you do that, but it's quite simple because it's just creating an account. And after that, you're going to install WandB in your notebook and then log into your account so that at least you can log your model parameters, and you'll be asked to provide an API key. So you can just click a link that will take you to your API key where and then you can just copy it in your notebook. If I'm too fast, please just stop me. And then after that, the next step is to set up your parameters. So by that, I mean your configuration. So this is how you set them. You can just set your batch size there, your number of epochs, your learning rate, and any other parameter that you're going to use. So this is just a dictionary, and you can easily still use it to set the different hyperparameters as you could. But you need to at least set them here so that they can be logged into WandB and you can be able to see what was in your experiment. So once you have your configurations, you can set them to WandB for the tracking to start. And then this is how you initialize WandB. So the name here is the name for your run. Every time you run it, it's going to create a new experiment. So ideally you should be changing this name. And then this project points to the project that's storing all your experiments. So it's also shown in the slides how you can create a project, and then you can just have your simple notes there and then tags. And then here you say the configuration. Actually, let me put it below here because it's going to expect a config variable. And then after that, this is just us creating dummy data to be used for this demonstration, setting the dataset class, creating your data loaders. And then these are the parts that Xiang was just showing us using screenshots. So I just won't go through them again. You have your model definition. You've created your model and put it on the GPU. And then this is the other interesting bit. So now that we have created our model, we can start watching it, which means you can start logging the network weights and every other thing that's in your model. So when you have this command, this is the trigger to WandB that it's about, that it should be watching the different hyperparameters in your model. And then after that, the next interesting thing is you can use the hyperparameters that were saved in your config file because it's just a dictionary. So you can access them from there and use them in your model. And now for the logging part, there are two ways for you to log output to WandB. One way is using run.summary. So when you use run.summary, it's going to create a column that's going to be rewritten. on every run. I'll show you the table for you to get a better sense, because ideally when you're training your model, you need to store, or you need to know the best accuracy as well as the best epoch, the epoch that gave you the best accuracy, because it will help you when you're tuning your parameters. So you can store this metrics in WandB, and then when you go back and check your model, you can understand how it performed. And a different way of logging is using the log command. So in the log command, different to this, the values won't be overwritten after every run. Instead, it's going to create new values, and these are the values that are going to be plotted on a graph. Yeah, and then the other bits are just regular code. But now let me show you how you use WandB. So here I had run 7 different experiments. You can see them here. And then you have a table that shows all the different parameters that you are logging into WandB. So here you can see I was tracking batch size, epochs, learning rate, train size, and trial, as well as epoch. So, okay, just look at these ones here. Let me just show you. So these are the values that were in your config, and they're going to be recorded in your table. And then I also showed you there are 2 different ways of logging parameters. So for the parameters logged using run.summary, they're also going to be created at the very end, and they're going to be logged and rewritten whenever you have a better accuracy, as well as record the epoch number. And then for the logged parameters, you can see them better in a graph. So let me just look at experiment 7, which was the most recent run. So I had logged validation accuracy, the epoch number, training loss, as well as validation loss. So you can still see them here. These are the 4 items that I had logged. And now you can see them plotted in a graph. And the beauty of WandB is it's a very useful way for you to track your experiments and for you to be able to visually see what worked and what didn't work well. So also let me just show you a graph where we have all our models. So this is not very helpful because I wasn't really tweaking the parameters as much. But if you had tweaked your parameters, the graphs would ideally be different. And then you can just hover around it and see which model performed better. So the beauty of it, it's just similar to you logging your parameters manually, but then it gives you more flexibility because it has graphs among other things. So I'm done with that bit. Is there any question about WandB?
I have a quick question. Thank you for this.
Okay.
So is this different from the process of saving the models periodically in case something goes wrong and we need to reload?
You can also save your model to WandB, but I just never did it in the last semester, but that's something you can consider. You can also go ahead and save your model to a drive or to your Google Drive if you're using Colab, or to a different storage if you're using AWS. It's just an alternative way, but you can still continue saving your model the way you've been doing it currently. I hope I've been able to answer your question.
Yes, thank you.
Okay. Okay, if there's another question, I'll just hand it over to Xiang to proceed with the notebook. I can see some questions on the chat. So Simran asked, what is trial? That's just how I was tracking the different runs. I named them trial, but you can just have your own system of tracking your different experiments. For me, I give them trial numbers. And someone with an Android ID asks if WandB is free. Yes, it's absolutely free. Are there other cool features in WandB interface? The coolest one I encountered last semester was when I was doing homework 2, where it could log the images after it had performed different transformations. So you had a way of at least seeing how your model was behaving, but you can explore the documentation to see other cool features that you can use. Okay, Xiang, over to you.
Yeah. So can I also my screen? Yeah.
We can see the notebook.
Oh, yeah. Okay. And I also attach some errors which is commonly encountered for you to reference, and I will simply explain some errors, and I will manually trigger maybe 1 or 2 of those on the notebook to show what will happen if you don't follow the general idea of the training. And there is appendix, and there are some maybe most commonly encountered error, and I will go over one by one. And first, if you encounter the value error, is most likely you have some data issues. And for this one, the number of samples should be positive integer values, but get 0. It means the data loader have no data. So
Then I'm sorry, I'm not sure if you're running something because you can't see anything on your. We can just see the notebook on your screen.
sorry, I in fact change to the slides. Yeah, so could you see the slides?
Yes, you can see the slides.
Yeah, okay. So if you encounter the bad errors, maybe like that, it means the data set don't have any data segments in it, and I will trigger this error later. And this is a type error, and this means you haven't changed the data type to a torque tensor. You may encounter this error in the next in the homework 2 part 2, because you will do a face classification task in the next homework, and at that time you will use a lot of image augmentation methods. So make sure you change the PIL image to the torque tensor at that time. There is a runtime error, and you can see some dimension mismatch in this error, and that's why I want you to check the data shape before you send them to the model. And once you send them to the model, you will get a lot of ambiguous runtime error like that, because PyTorch itself doesn't debug for you. And this is another runtime error. So this is some errors because the network architecture is not consistent to the model you want to them load. And for the data parallel, I mentioned if you want to use the data parallel or the network, you saved will have another will have a worker named module. So when you want to reload the data saved by the data parallel, you need to add another character module to the saved checkpoint. This is the CUDA arrow which I illustrated at the beginning, and this means the model trained on GPU cannot influence on the CPU. And if you want to load your model, which is saved on GPU, you need to explicitly mention that the map location is CPU. You will also use it when you want to use a distributed data parallel. For this one, it indicates that the target class number is larger than the network output neuron number. I will trigger this arrow later in the notebook too. This is another arrow which indicates that the data are not in the same device. If you guys can check this appendix if you encounter any maybe errors, and see if you can get the solutions from here. It is out of memory. It is a CPU memory out of CPU memory error. Yeah. If you encounter this error, you may use the slightly less batch size. And this one is another very common error. And I'm not sure if you will use a PCE loss in the next homework, but for me, I always I make this error a lot of times in my homework too. And this